Hi, my name is Steve Helderly. This is my Project Lead the Way course. And for the past week, students have been working on what's called a survival challenge. They had to imagine themselves in the future and the planet running out of resources, and they had to create machines to help civilization. For a little bit of fun, we added a little bit of a zombie apocalypse to it. And in just a minute, you're going to see all the different machines they made, the types of mechanisms they used, and how they're going to bring mankind back from the brink of extinction. Thanks. Okay, please introduce yourselves and describe the specific task assigned to your group.
My name's Peyton.
My name's Lindsay.
My name is Jay.
And our task was to build a machine that can go up and down and side to side so that people can move heavy medical equipment without much labor.
And what type of mechanisms did you build on your machine?
We use a cannon follower to move the heavy equipment up, move the metal equipment vertically up and down. And then we use a crank and slider to move the heavy equipment horizontally so it would go back and forth down the hall.
Can you explain the input and output for your machine, please?
For the cannon follower, the input was rotary and the output was reciprocating. And for the crank and slider, the input was rotary and the output was linear.
And where could a machine like this actually be used?
A machine like
For the cannon follower, it could be like used as an elevator. And for the crank and slider, it could be used for like a train wheel. Wrong way. Okay.
Okay, thank you very much. Please introduce yourselves and describe the specific task assigned to your group.
Okay, I'm Jordan,
I'm Jacoby.
I'm AJ.
and we had the task of building a rover that can go over rough terrain. It has to hold survivors, and it has to be able to shift from two-wheel drive to four-wheel drive.
And what type of mechanisms did you build for your rover?
We built a simple simple chain drive so we can make it go to four-wheel drive from two-wheel drive and back. And they helped make it so we can go from two-wheel drive to four-wheel drive because we had to do that. And the type is rotary movement.
Okay, so can you show us, can you demonstrate how some of those things would work?
To get it from two-wheel drive to four-wheel drive, you have to take the wheel off, take this off,
We lost a boat.
put the wheel back on, and then you're in two-wheel drive.
Okay, very good. And can you explain the types of movement, like as far as input and output on this machine?
Right here it's rotary because it goes in a circle, and
And you're supposed to have a space for survivors. Where are survivors
Yes,
going?
survivors
they can sit
go
right here.
sit right here, or if we have the researchers can go up here to search for.
See if there's any survivors around.
And how about the, what are those hook things on the front? What are the claws for?
These are to, like, if there's a survivor that is like lost, you can grab them and hoist them up, or you can just like grab things in your way.
Yeah, if there's anything in your way or anything trying to attack you, you can just grab it.
Choke it out.
Very good. Nice job.
So I'm Colin,
I'm Joseph.
I'm Cameron.
and our task was where we had to make a machine that provides food and shelter and water. It has to be a 10 by 10, only one input, and do all three tasks.
Explain the task again. So you have one input, and that input has to, do I remember correctly, it has to chop wood?
Yeah.
What else does it have to do?
It also has to grind grains, which is right here, and pump water.
So can you give us a quick demonstration of that? Okay. And explain the mechanisms that you built for your machine.
When you move the crank, it powers like the saw to chop wood, and it grinds the grain, and also pumps the water all at the same time.
And what types of inputs and outputs did you have for all of these?
We had the rack and pinion. It pumped water by going up and down.
What else?
It just powered it powered the saw.
The rack and pinion powered the saw?
Yeah.
What was your input on this?
The crank,
And what type of input was that?
like a wheel,
Rotary.
rotor.
All right. Good job, guys.
I'm Logan.
I'm Alex,
I'm Owen.
and our task was to build a machine that will rotate a soil collection dish to power the scientists' labs. And the requirements that the machine had to have a gear ratio of 1 to 5, it needed to be angled toward the sun, and it must be able to follow us.
Okay, can somebody demonstrate that for us, please?
So it would just move around like this to follow the sun, and someone would have to crank it at different times of the day. So
To follow the sun. Good idea.
collect
And can you tell me what kind of mechanisms you built for your machine?
We used a beveled gear, and we also used wheel and axles so that it could spin.
And what type of input did you have for your machine?
Our input is rotary, and our output is as well rotary.
What was your output?
Rotary.
Rotary. Okay. Nice job, guys. Thank you very much.
I'm Anthony.
I'm Colton. And I'm Harry.
Our specific task was to build a vehicle that could switch to two-wheel drive to four-wheel drive, and then it could pick up survivors and carry survivors and go over rough terrain.
And what type of mechanisms did you build for your vehicle?
We used a chain drive to go around the gear and power the wheel. The chain is connected to 4 gears on each wheel, and that's what spins the wheels to go from two-wheel drive to four-wheel drive.
And can you explain the type of input and output that you used on your machine while you give us a quick demonstration of how it works?
The input is this little gear right here. You spin that, and that's what spins the wheel. Spins all 4 wheels on both sides.
Very good. Thank you very much. All done. Please introduce yourselves and describe the specific task assigned to your group.
I'm Jacob.
I'm Kamayu.
I'm Cade.
Our task was to build a mechanism for all members to survive, and it must cut wood, drill for water, and grind up food.
Can you give us a demonstration of what's going on? At each
That's
step.
to drill the wood, and this is to grind food. Cut the wood, not drill the wood. That's to grind the food, and then to drill water, you just lift this up, and it goes into the ground and
Very
drills.
good. And what type of mechanisms did you use for each of those?
The type of mechanism we've used were a simple gear train to make the grinder for the food. Also, we used the lead screw to attach the parts and make the drill for water.
Very good. And I believe that this one you could only have one input, correct?
Yes.
So one input worked everything. And what was that type of input?
The handle right here.
And what type of input is that?
Rotary.
Rotary. Very good. Thank you.
I'm Zach Bram.
I'm Ryan Lively.
I'm Marco Garcia. Our specific task was to create a machine to transport heavy medical equipment, and it has to be able to go from first floors to second floors and across those floors, and to create a cardio regulator.
Can you demonstrate?
Yes. So this is our cardio regulator. You spin this wheel, and maybe like an animal or something could spin that for you, and you could run on this, and it basically will get your heartbeat going so that you can monitor it and make sure you're healthy. This is the lift to help lift the heavy equipment. You turn this and it'll go up and to get it to the second floor. And then these are the wheels like to help move. And our mechanisms, this is linear and rotary to help this move up. We have rotary for the wheels to help move and rotary for the cardio regulator.
And what types of input did you have?
We have a rotary input here, another rotary input here, and a third rotary input here.
Okay, very good. Thank you.
My name is Caleb.
My name is Kevin.
And I'm Garrett.
Our task was to be able to cut down wood, grind up flour, and pump water.
In 3 different stages or all at once?
All at once.
All at one time. Okay. What kind of mechanisms did you build for your machine?
Make bevel gears. Well, we did bevel gears.
Can you demonstrate these?
Yes.
And what's going on?
Rotary.
No.
As we spin this, this piece connects to this piece, and this piece is grinding up for food. This piece right here is chopping down wood, and this piece right here, look underneath, it's drilling for water.
Very good. And can you explain your inputs and outputs, please?
The input is the lever, I guess you could say, and then the output is the I just don't know what the output is.
Are they rotating? Are
Rotate-
they
they're
reciprocating?
Rotating, I think it's about it, rotating.
Okay, thank you.
I'm Zach.
I'm Riley.
I'm Joe.
And we had to make a solar panel that spin to around with the sun and had to be around the corner.
How about gear ratios?
Has to be 1 to 5.
Can you explain that?
The smaller one has to turn 5 times, and this has to turn once.
And could you give us a demonstration of your mechanism, please? Explain your movement, your input, and your output.
Well, this would be rotary.
What's this?
The crank.
That's your input?
Yes, and that would be rotary. And so would the solar panel up here, and that would be the output.
Thank you very much. Please.
I'm Nick. I'm Brendan Coleman.
I'm Dylan Wilson.
Our task and requirements were to search for survivors in this zombie apocalypse, and it had to change from 2-wheel to 4-wheel drive, which is right here, and you could take off the chain and it would change. It had to travel on rough terrain, which is what the teeth on these tires are for, and then it had to have a place for the survivors to sit that we found.
And what kind of mechanisms did you build on your machine?
We built like a elevator right here if we need to lift up some survivors or smash zombies. And then we have
Help them out.
We have a gear train here.
we have that gear train. We have a lever right here, so it can go to 2 gear to 4 gear if we take off the chain. And we have the seats for the survivors.
Okay, and can you explain your input and output, please?
Our input is the gear here, or
And
the
what
lever.
what kind of an input is
It's
that?
a rotary,
Okay, very good.
and it outputs a rotary.
By moving it.
Yeah.
Thank you.
You're welcome.
I'm John,
And I'm Jared.
and we had to make a machine to transport heavy medical equipment.
Our task works, and because it spins a handle, which makes these, which are kind of like gear, elevator system type things, they're kind of covered by the walls so that the items don't fall off that we put on.
We also had to make a cardio regulator to monitor our heartbeat.
And you could use this machine to transport items in multiple different directions, because it's kind of got like a little spinny base, so I guess you could like move it around.
In what different directions can you go?
Vertically and horizontally.
Okay. And can you explain the movement that you used as far as input and output?
This input is a wheel, it's rotary, and the output are these gears, which are also rotary.
Okay. Thank you very much.
Thank you.